Hello, this is Sireena Massoud. Today I will talk about the biocide hexamine, or in other words, hexamethylene tetraamine. For general properties of hexamethylene tetraamine, it's also known as hexamine, methenamine, or urotropine. It is a hydrocyclic organic compound and it is a polar organic solvent. Also, it is useful in the synthesis of organic compounds, including plastics, pharmaceuticals, and rubber additives. For hexamine physicochemical properties, it has a chemical formula of CH2, 6, and 4, as seen on the structure above at the right, and it has a white crystalline solid appearance. It's highly soluble in water with a solubility of 85.3 gram per 100 ml. It has a molar mass of 140.186 gram per mole, and it has a fishy ammonia-like smell. It has a melting point at 280 Celsius degrees. Hexamine is soluble in chloroform, methanol, ethanol, acetone, benzene, xylene, and ether. There are many factors that affect the antimicrobial activity of hexamine. Three of the most important factors that affect hexamine antimicrobial activity are metal ion, where it plays an important role in enhancing the antimicrobial activity. Second, the polarity. Any reduction in polarity will increase the antimicrobial activity of hexamine. As well, the pH. A pH of 5.5 can cause inhibition in the bacterial growth. For the spectrum of activity, hexamethylene tetraamine is formed when formaldehyde reacts with ammonium ion, and this property was used to determine the formaldehyde contamination in the air. As well, it is most effective in situations where the urine pH is low, and there is time for hydrolysis of hexamine to achieve sufficient concentrations of formaldehyde. For hexamine mechanism of action, it does not have any antimicrobial property in alkaline environment, where it is the pH less than or equal to 6. On the other side, in more acidic environment, where the pH is less than 6, it is hydrolyzed to formaldehyde, where formaldehyde is highly bactericidal and it has no specific antibacterial activity, and it works by denaturing the proteins and the nucleic acid of the bacteria. Some of the main applications of hexamine. The main uses of hexamethylene tetraamine are: it is used in the production of powdery or liquid preparation of phenolic resins and phenolic resins molding compounds, where it's added as a hardening component. It's also used as a binder, like in the brake and clutch linings. It is an abrasive product, non-woven textile, and formed part produced by molding processes and fireproof materials. It's also used as a molecular building block because it has a self-assembled molecular crystals. It's also used as a mandelic acid salt in medicine to treat urinary tract infection. And as well, it's used in foundry, tire and rubber, and phenol formaldehyde resin industries. Examples on commercial products of hexamine. First example, we have the product named Hyprex, which is a hexamine hyperate. Hyprex has an antibacterial activity, and it's used to eliminate or suppress urinary tract bacteria associated with chronic or recurrent infection. It can be used as a short or long-term treatment, and the way it works is that it helps acidify urine and maintain low urinary pH. The second product named is Aspert, or hexamine fuel tablet. It's a solid fuel in tablet form as seen in the picture above, and it's used for cooking in camps by campers and militaries. The third one is Darkalma. Darkalma is used to relieve local symptoms such as inflammation or hypermotility and pain, and to lower urinary tract infection. And while I was reading about it, I noticed that it's not found in Jordan. This medicine is not found here in Jordan, Darkalma. As an additional uses of hexamine, They add it as a food additives as a preservative with a number of INS 239. And it's also used in creams and sprays to treat excessive sweating and concomitant odors. Thank you so much for hearing.